Go ahead and start. So that's what Jacopo is going to be talking about geometry measure of spatial extension.
Thank you, and thank you everyone for being here until the end of the conference. So I'm going to talk about geometry and measure of spatial extension. This is a part of my PhD project. I will follow this index. So first of all, I will give an introduction about why we should care of spatial extension and why there is debate in literature regarding also other metaphysical topics related to this concept. I will introduce the two logical theories that we will discuss, in particular mereology and the theory of location that I'm going to use, even though we should be a little bit more, we should talk about theories of location more generally. And I will give you two accounts that you can find in the literature. The first one, spatial extension as merological extension, and the second one, spatial extension as Lebesgue extension. And it will motivate why we should arise two challenges to these two accounts. And in particular, I will try to overcome these two challenges through a new definition of spatial extension, that is spatial extension as extension simplicity. I will give on top of this also what I will call measures for this new account, and I will also address a problem that one might want to arise for this account and also for the spatial extension as Lebesgue extension, dealing with what in the literature are called non-measurable locations. So in general, philosophers have been committed to the concept of spatial extension when addressing the concept of material objecthood or the concept of physical being. In particular, Lower and Markosian have discussed the idea that we can capture what a physical or material object is completely in terms of spatial location or spatial extension. In particular, it is said that a material X is a material object if and only if that object occupies a region of space that is extended. But the relevance of this concept also extends beyond the material objecthood. And in particular, we can find discussions about spatial location and spatial extension, in particular the second one, even though these two concepts are conceived in a dispositional way. Or the concept of spatial extension is also, you can find this concept also within debates regarding the metaphysics of persistence, or debates regarding certain solutions of spatial composition questions, or also dealing with more general metaphysics of properties. But since we have to draw a line somewhere, we have to say, and we will endorse the following thing that is proposed by Dalhousie in 2023, that to be extended, and when I will talk about extended or extension, we will implicitly refer to spatial extension, we have to guarantee that to be extended is to have some positive degree of extension. So in the debate, philosophers have argued that we can opt for a count of spatial extension such that spatial extension is merological extension, and I will introduce it later on in 1 second, or spatial extension as space-time metrical extension, or spatial extension as Lebesgue extension. And I will focus in particular on the first and the second, and on the third, not because I think that the second is not of relevance or of importance, but simply because I think that the two challenges that will arise apply in particular to the first and to the third one, even though obviously also the second one that is proposed in the literature by, for instance, Barra, Bianco, also many others, will be of extreme importance in the debate and also to be discussed separately. So in order to discuss the first and the third count, we have to introduce, as I was mentioning to you before, mereology, actual mereologies, and the theories of location. Mereologies are those theories that try to formalize the concept of being a part of. And from now on, I will consider this concept, and this is the symbol of being part of, okay, as a concept that you can obtain positing partial order, okay, on the concept of being part of, and also requiring for regions of space or material objects, depending on which ontology you are referring to, weak supplementation and strong supplementation. In particular, weak supplementation says that X is a proper part of Y. This entails that there exists a Z such that that Z is a part of Y and it's not completely disjoint from X. On the other hand, strong supplementation, that implies also weak supplementation, that says that if X is not a part of Y, then there exists a Z such that that Z is a part of X and it's not completely disjoint from Y. And since I will work from now on just with material objects on one hand and the spatial regions on the other hand, I will require the two following mereologies. The first one is minimal mereology, such that the being a part of is formalized in terms of partial order and weak supplementation, and mereologies for spatial regions that is formalized by extension of mereology, that you can define with the actions of a partial order together with the strong supplementation. And I will take for granted from now on, even though there is debate in the literature, that when we talk about a material object, we're not talking in any case about a spatial region. So positions like supersubstantivalism are completely ruled out in this context. And in order to simplify things, I will also require that when we talk about spatial regions, actually we can convert our vocabulary inside theoretical terms. So when I say that X is a part of Y and X and Y are regions of space, actually I'm simply saying that X is a subset of Y and vice versa. And what about the theories of location? Theories of location are typically based on a notion, the notion of being a part, being exactly located at. So exact location, okay, this is proposed by Gilmore in 2018, but also by other philosophers before, like by Parson in 2007, and it's such that X is exactly located at R. Okay, this means that X, that can be a regional space or a material object, exactly has the same shape and size of the region that it occupies, and stands in no spatial temporal relations at the region it occupies. And I will require that we can talk about exact location of material objects or regional space. So the Lx is a total function associating each spatial entity to the regional space in which that entity is exactly located. In terms of the exact location, we can also define weak location, saying that X is weakly located Y, if and only if that Y or that X is not completely free of X or Y, respectively. And we can also define another action that I will use later on, that is expansivity, saying that if X is a part of Y, and Y is exactly located at R1, then not only X is exactly located at R2, that is something that also follows from weak location through a principle that in debate is called exactness, but that R2 is a part of R1. So the parts are located within the whole, where the whole is located, okay? So now we can give the two accounts, so spatial extension as merological extension and spatial extension as Lebesgue extension. That I will call semi and Sada respectively. So the first one, we have to introduce a notion, the notion of being an atom. So X is an atom in case that X does not have any proper part. And in this sense, we can define immediately what being extended means for those who support the mereological account. Something X is mereologically extended if and only if that X occupies a regional space that is not atomic. So to put it in different terms, take for instance a material object, but we can do the same with regional space, take the exact location of that entity. If the exact location of that entity is composed at least of 2 points, then that entity and also that region is complex, merologically complex, and so merologically extended. But this account does not provide a measure of extension, so it's like the word is divided in two sets. Things that are extended and things that are not extended. But if you ask to one of those who support this account, what is the measure of extension of this entity, that person will not be able to answer this question. I'm not saying that in the debate there were no proposals in order to address this problem. A way to do so was, for example, proposed by someone dealing with the Hilbert arithmetic, and so on and so forth. But they are not accounts that we can define using just the framework that I have introduced, that is particularly large and wide. On the other hand, you have spatial extension as Lebesgue extension, and you have to define, first of all, the Lebesgue measure. So Lebesgue measure is a mathematical tool that is used in mathematics, in particular in measure theories, but also in physics and so on, and such that its domain is the sigma Rn, that is the so-called Borel sigma algebra on Rn, and its codomain is composed of all the positive real numbers together with the symbol of infinity. And the extension of the set S, according to this account, is just the Lebesgue measure of S. And so the extension is the Lebesgue measure of Lx. I want to call that Lx is the exact location of x, and something is extended at that point, even though if this quantity is greater than 0. And it is unextended according to the Lebesgue account, even though if this is mean Lx is equal to 0. And this account was particularly endorsed, as was mentioned in the slides before, by Dalhousie or Fano and Dalhousie. And however, also in this case, we have some issues. Certainly, this account can accommodate those who say, well, the spatial extension as merological extension does not provide a measure of location, because in this case, we can provide a measure of location. But in any case, Selle provides a spatial entity with extension only if the exact location is Lebesgue measurable. So if and only if the exact location is a Lebesgue measurable set. At the same time, we have to say, well, the exact location is of importance for an entity, because depending on the space in which we find the entity, we can define its measure, its spatial extension. But if we go on upper dimensional levels, we have to say, well, the same entity comes as unextended, for instance, and I will give you an example in 1 second. And in order to address this problem, we can have two solutions. The first one says, well, we can attribute to the space where we find the exact location a privileged status. So we say that something is extended, even if it is Lebesgue extended, according to the account that we have just mentioned, where we find the exact location. So that particular space where the object is exactly located. But on the other hand, I mean, we might want to not say that we assign a privileged status to a space where the object is exactly located. So we might want to say, well, we can cross-cut all the dimensions of spaces where the object can be defined as extended according to our account of spatial extension. But in that case, we have to say that X is extended, even only if it is extended in all the spatial dimensions that we are considering. And in this account, it turns out that an entity is always unextended, because you will have, for instance, an entity exactly located in R1, that is our formalization of space. In this case, it is, for instance, extended because its measure of location is equal to 1. But if you go to upper dimensional spaces, R2, R3, and so on, the same entity, according to the Lebesgue measure, is such that its location is equal, the measure of its location is equal to 0, so it counts as unextended. So I propose what follows. So we have problems with the merological account, we have problems with the Lebesgue account, and we want to accommodate some facts that ABC sum up. So we want an account of spatial extension such that that account is adimensional. I don't want to say that something is extended just because I consider a particular dimension where the object is exactly located, but also if I look at upper dimensional spaces, I can nonetheless say that the same object is extended. So the dimension of the space should not be of relevance in this case, unless you want to say that something is extended on one space and not extended on another space, but you have to give a motivation for this. And at the same time, we would like to have the same benefits of the Lebesgue measure. So the benefits of the Lebesgue measure were that we are able to say how much an entity is extended. If I give you this line with the notion of Lebesgue measure, I can say, well, this line has length equal to 1, equal to 2. So I'm not just able to say this line is extended or unextended. I'm able to say exactly how much this line is extended. I can do that also for upper dimensional levels, because the Lebesgue measure says to you, okay, if you give me a second dimensional object, I will give you the area. A three-dimensional object, the volume, and so on and so forth. So we want a notion of spatial extension, okay, such that it is defined through a measure of spatial extension, but not just defined in terms of E. We want exactly to have a measure of spatial extension that somehow pops up from our definition of spatial extension. And so I propose the following account that actually you can find in a footnote of the article that I mentioned you before, like Dalhousie in 2023, even though in that footnote this, you don't find exactly this definition because it doesn't use what I will call projection, and in any case, you don't find exactly all the motivations and all the discussion that this notion deserves. And so according to the extension simpliciter, X is extended, spatially extended, if and only if it has a part such that the projection on one-dimensional space of that part is such that the measure of location of it is greater than 0. So take an object, take a part of it, take the exact location of that object, project that on one-dimensional space regardless of the particular decomposition of space and the particular projection of it, measure it. If the measure of it is greater than 0, then the object is extended. Why someone should say something like that? The basic idea, for those of you who think that maybe this account might be cumbersome, is that we have a conceptualization of spaces such that we don't consider just one space. We have different levels of space. So fundamental space that in our account is just R1, then you have R2, and so on. So we want to say simply that something is extended if it contains a part, and if you can take the exact location of that part in a one-dimensional space, and that location is one-dimensionally extended, because it cannot be extended, more or less than that, because you consider exactly the basic level of the space where an object can be located. So, for instance, take this example. Take the interval 0, 1, it's a subset of R1. So, according to the Lebesgue account, okay, 0, 1 is extended in R1, because you take the Lebesgue measure of 0, 1, and I can tell you that its Lebesgue measure is equal to 0. So it is greater than 0, so it is extended. But what about if we consider 0, 1 embedded in R2? Because in any case, we can consider the interval as embedded in R2. Then that same interval comes as unextended in R2, and also in R3, and so on. So either we go with the option 1 that I mentioned, but we have to recognize the privileged values to the space where we have the exact location of an object, or you want to cross-cut among different dimensions. But at that point, you have to recognize that an entity is extended somewhere, unextended on other spaces, and at the end, if you consider that X is extended, even only if it's extended in all the spaces where the object, the location of the object can be defined, then you have the object is unextended. But if you use the spatial extension as extension simpliciter, you have that not only R is extended in R1, but is extended also in R2, basically because it always has a part itself that is one-dimensionally extended under modulo the fact that we consider a projection, and the same with R3, and so on and so forth. And one might want also to ask, what are the relations between this account and the meteorological account and the Lebesgue account? Well, I didn't provide here all the proofs, but I can tell you that these conditionals hold, respectively for regions of space and for material objects. So you have a set composed of all those spatial entities that are Lebesgue extended. Then that set is a subset of those entities that are extended simpliciter, and then this set is again a subset of those things that are meteorologically extended. And this is true for regions of space. You can obtain pretty much the same thing also for material objects, model the fact of considering expansivity the principle of location that I mentioned you before, defined not just in locational terms, but also in methodological terms. And so the extension simpliciter seems to be a notion in the middle between the two definition of extension provided in the debate, the one at least that we considered so far. So what can we say about the desiderata that I mentioned you before? Well, certainly the spatial extension as extension simpliciter, okay, is a dimensional in the particular definition of the a-dimensional that I gave you before. So the fact that it's not affected by the particular dimension which an object is exactly located. We can consider the same object from a different perspective, okay, from an upper dimensional level, and nonetheless the same object is extended, not unextended. B is also satisfied because it is formulated using the Lebesgue definition of extension, in particular one-dimensional, the measure of location, me, on a one-dimensional level, R1. But what about C? Because we wanted to say a little bit more. We was not okay with the fact that we wanted to provide that definition of spatial extension defined using a measure of extension, like the Lebesgue measure, but we want to exactly say, like Sally was doing, how much this entity is extended. And actually we are not able immediately to say, well, according to this new account of extension, we can exactly attribute this measure of extension to this object. But it's possible to do so in a way that is compatible with the account, compatible in the sense that it does not contradict the account, that is defined only using the methodology and the theory of theoretical aspects of the theories of location that I mentioned to you before. So from now on, I'm considering just the Lebesgue measurable sets. I will come back to the non-Lebesgue measurable sets in 1 minute because there will be a problem also for another account. So we have X, for instance. So X, take a material object for simplicity. You have the exact location, Lx of that object, and we consider that this Lebesgue measurable set. So at that point, Lx can be extended simpliciter or not extended simpliciter. So if Lx is not extended simpliciter, we simply say that the measure of its exact location is equal to 0, because we don't want to say that something can count as extended simpliciter while having a measure of location equal to 0. We want to say, as this metaphysical principle states, and it can be obviously on which we can obviously debate, that provided spatial measure of extension, a spatial entity cannot count as extended if its spatial measure is null. So we have a condition of something is extended simpliciter or extended, okay, if and only if the measure that we provide in particular, okay, is such that is greater than 0 for that particular object. So considering the Lx that was a Lebesgue measurable set, we simply say that if Lx is also Lebesgue extended, we simply say, well, the measure of location and the measure of extension of x, the simpliciter one, is exactly identical to the one where we had for the Lebesgue account. So M as x is equal to the Lebesgue measure of the exact location of x. On the other hand, if x is not extended simpliciter, well, according to the metaphysical principle that I stated, we have to say that the measure of location of that entity is equal to 0. Otherwise, we would have something with a positive degree of extension that is not extended simpliciter. But we want that the metaphysical principle that is stated holds, okay? And what about if x is extended simpliciter, okay, while being exactly located unknown at a Lebesgue measurable set that is not Lebesgue extended? Because we can have, according to the conditionals that I stated before, something that is extended simpliciter, okay, while not being Lebesgue extended. Well, I say that we can extend the definition of a Lebesgue measure that we provide, okay, extending that definition using what in the mathematical debate are called infinitesimal numbers. So actually extended real numbers such that these numbers are always greater than 0, but always less than every single natural, like normal real number. And so we can simply assign, okay, an epsilon to those particular objects occupying regions of space that are extended, okay, simplistically extended, while being Lebesgue unextended. But at this point, provided this notion of measure for the simplistic notion of extension, we are left with a problem, because I consider just those locations that are Lebesgue measurable. But what about those who are not Lebesgue measurable? And this was also a problem for Sala, because Sala was saying, okay, give me an object, give me the exact location of that object, its extension is the Lebesgue measure of the exact location of that object. Thanks, but you can do that only in case the exact location is Lebesgue measurable. So what about the case in which this does not hold? So we can have three different solutions. The first one is simply that you can always extend the Lebesgue measure, okay, with the domain of a Lebesgue measure with a set that is not Lebesgue measurable, and it's an incompatible extension with the Lebesgue measure itself. So you can do that, but you cannot do that for all the sets, okay, in the power set. So for all the elements in the sense of the power set. So you can do that for some, but not for the others, for in particular a finite number of sets. So it's not a solution that is particularly appealing. On the other hand, you can say, well, this notion of not being Lebesgue measurable doesn't make sense to me at all, because it's just a mathematical feature. It's just popping out of the blue because of the particular logical framework that we are using, caused by the axiom of choice, in particular Zermelo-Frankel plus the axiom of choice. Because if we want to get rid of that axiom, and in particular we are not committed to that axiom in no way, because the theories of location and the meteorology we consider are not committed to the axiom of choice under consideration, okay? Well, if we get rid of that axiom, and according to our account we can do that, well, this division is provable to be meaningless, because there is no division between Lebesgue measurable sets and non-Lebesgue measurable sets. Everything is measurable to some definition, according to some definition of Lebesgue measure within the framework of Zermelo-Frankel without the axiom of choice. But, I mean, if you want, for some reasons, dealing with philosophy of mathematics or for other reasons, maintain the axiom of choice, you can also have a kind of metaphysical argument in order to say, well, we should not care of those locations that are not Lebesgue measurable. Simply due to the fact that if you take an object exactly located in a non-Lebesgue measurable set, at that point you can decompose the set, and according to the Tarski paradox, you can compose exactly two, not numerically, but geometrically identical objects, such that object, okay, X is exactly located at that regional space, for example, one of the first decomposition, and also on a second regional space, without these two regional space overlapping each other. So at that point you will have the multi-location of an object, and you might want to not endorse this principle. So it's just a metaphysical way to say, well, we should not care of those locations that are not Lebesgue measurable. And so in this case, we're fine with providing a measure, okay, of extension just for those objects exactly located at Lebesgue measurable sets. And so also Selle and Cies can get along with this. So this is a short list of references, and I really thank you for the attention.
I guess it's time for Marissa's comments.
I guess so. Yeah, thank you, Jacopo. This paper was very interesting. I really enjoyed reading it. Took effort, but I enjoyed the effort. I thought that, so I have absolutely no criticisms about any of the technical details. I really especially enjoyed the discussion at the end of the non-Lebesgue measurable sets and in relation to the foundations. Now, everything, the details of the arguments were all very clear, and I certainly think that you succeeded in coming up with this notion of spatial extension that fit your desiderata. What I would like to hear more about was I was just a bit unclear on the philosophical motivations for some of the desiderata. So in particular, it seems as though a lot of the driving force behind the development of this new notion of extension is that the feature of being spatially extended should not be relativized to the dimension of the location, the space that it's in. Right, so that's where I was being confusing. In my comments that I sent to you, I said location when I should have meant just the space. So, right, so we have, we'll have some entity. It's going to have an exact location. That's just going to be basically the region of space that it occupies. And you didn't quote it in the paper, but in the, in the talk, you did quote it in the paper. So the definition says an entity is exactly located, an entity X is exactly located in region Y if and only if, first, X has exactly the same shape and size as Y, and second, X stands in all the same spatial or spatiotemporal relations to other entities as does Y. So I assume in this definition they meant other entities in the same space as Y, in the ambient space. So it seems like it's built into the definition of exact location that it should include some kind of information about its position in the ambient space. So so this is just kind of like an observation that, okay, so the desiderata says if we have a one-dimensional line segment in R1, say it's located in the region, the interval 0 and 1, that should have extension 1, and it should count as an extended entity, and it does, so good. But if we take that same thing and place it in the plane, a two-dimensional space, so now we have to put it somewhere in the y direction, so we'll say we put it along the x-axis, so it's just along the x-axis at 0, 1. Now, the desiderata, we want this to count as a spatially extended entity, but the Lebesgue measure will say it doesn't, because this Lebesgue measure is going to be 0, because the Lebesgue measure is relativized to the ambient space that it's in. And this, this kind of seems to be built into the definition of exact location that I just mentioned, because it mentions standing in the same spatial or spatiotemporal relations to other entities in the space. And if that's a two-dimensional space, you're going to need another coordinate to kind of specify those relationships, sort of thing. So, if this notion of exact location is supposed to be kind of at the heart of our notion of spatial extension, that to me gives me some reason to think maybe it's not so out there to think that whether an entity counts as spatially extended should be dependent to some extent on the dimension of the space that it exists in. Now, in your talk, you mentioned, when you brought up this desiderata, you said something like, somebody who thinks that it should be relative should offer justification for that. I kind of thought the ball would maybe be in the other court, because here we are taking this this notion of spatial extension, Lebesgue extension, and putting a lot of writing this excellent paper to come up with this alternative. So I would think there would be a positive motivation for really wanting it to not be relativized. And then just kind of lastly, how long have we been talking?
6 minutes.
Okay, so yeah, I'll just wrap up by saying, backing away from the mathematical details and just thinking about I'm assuming that this notion of spatial extension is supposed to be, dovetailed with the historical conception, like Descartes' necessary feature of material entities. And I also just kind of wonder why this is even that much of an issue or a question. I mean, if we are, so if we're talking about just, three-dimensional space, three-dimensional objects, it doesn't really come up, right? Like if we could have an unextended space-time point in 3 dimensions, that's gonna be unextended on all accounts, I think. And then I'm just, trying to think about like, if I saw like a 2-dimensional triangle, floating by and like it's actually 2-dimensional, like disappears when I see it side on. I don't know whether I want to say that that's extended. Maybe indeterminate. I don't know if I want to say it's completely unextended. But yeah, that's just basically, I really, really enjoyed the paper. The details were fun, and I think it would just be great to just like hear some like philosophical reasons for motivating this exciting project.
Thank you very much for. Yeah, thank you for the comment. I think to be absolutely fair to the paper and also to a part of PhD project, but I mean, so the first motivation is based, I would say, the motivation for considering an adimensional aspect when we want to give a new definition of spatial extension is given by the literature. I mean, generally also the philosophers that I mentioned you before, talking about not just spatial extension per se, okay, but talking about the spatial extension related to material objecthood or other concepts, are not considering exactly the feature of dimension. So I'm not saying that the dimensional feature must be ruled out some way, also because I mean obviously that's of particular importance, otherwise we would not able to distinguish a 3-dimensional space from a 4-dimensional space. But because I mean the dimension of these two spaces are 3 and 4 respectively. The point is that in the literature, I mean this kind of different does not pop out. I mean at least not in the vast majority of the literature, considering, for instance, the metaphysics of properties, located somehow, okay, in space-time, instantiated in space-time somehow, without discussing exactly what space we're referring to, So I simply wanted to give an account of spatial extension, responding to the need of some philosophers who want to say, well, the dimensional features are important. We have to recognize them when we want to distinguish two spaces, a 3-dimensional space and 4-dimensional space. But it's not the case that if I have a particular property, maybe, the property of being spatially extended, the dimensional feature is important to define that. So I mean, it was simply a way to provide those philosophers with a way to take in consideration the dimensional feature on the one hand, because in any case the definition of the spatial extension that I gave is defined consider one-dimensional level, okay, the basic one that I consider R1. On the other hand, I wanted that they can be a little bit flexible about the spaces that are considering. Otherwise, we should always ask to them, well, what type of space you are referring to in this case? Because if you talk about the extension, you always have to talk about the extension relative to something and not to something else. And also, so this is, I would say, the main motivation. But in any case, I use, as I was saying before, a notion of dimension in the definition of extension simplicity. So I'm not saying that being spatially extended is something that can be defined like, in the mereological account, regardless of the geometrical dimension. I'm saying, well, dimensions are important, but at the very least, one dimension is more important than the others. The one of the basic level of the reality of the space, if you want to say that in these terms. So I consider like spaces constructed out, okay, at different levels. Okay, so you have R1 or 2. You might want to say, well, you should consider just one space, and not different dimensional levels. But if you construct the reality in this way, and apparently there is at least one reason to consider that we might be located in a four-dimensional manifold, but at the basic level, we can still talk about in quantum mechanics of a space that is not exactly our space, modulo the fact of considering different formalization of space or dimensional level. So if you construct the space in this way, you might want to say that something is extended if and only if at the end it has a microscopical part that is extended at the basic level. Okay, so like I don't want now to. I'm not an expert in philosophy of physics, but if we think for instance, strings are necessary, and we think that strings exactly construct out all the reality through some logical principles, we might want to say, well, everything that contains at least something that is a string is extended, modulo the fact of saying, well, that string is extended at the basic level. And another fact, I obviously implicitly endorsed that the space, okay, is formalized by real numbers. Okay, it's a very simplistic way of doing so. But I simply took for granted the debate provided by Dalhousie, or maybe also other people studying, these topics at least at basic level to see if they make sense, and then proposing to elaborate them using formalizations of space that are not exactly that simple. You might want to say that points are extended or unextended, or that points do not exist at all, or so on and so forth. But just the last thing before I go on. So I've been thinking about the second part of your comment a little bit. And I mean, if we're in this room and we recognize to be in a four-dimensional space, would you say that this is extended, this square or rectangle? I don't know. This square is extended or unextended? I mean, I will say that this square is extended, but the degrees of freedom of this, okay, are just two, even though we are embedded in a four-dimensional manifold. But in any case, we want to say that this square is extended also in a four-dimensional manifold. But the Lebesgue measure, so the challenge is the Lebesgue measure, my Lebesgue measure living in a four-dimensional space that is me R4, is such that if it is applied to this square, it returns the value 0, so it is unextended. And so, I mean, this new theoretical framework is just a way to provide the debate with something more of discussing about.
Questions?
Awesome talk. Super interesting. I'm going to steal the projection stuff. It's super cool. So this seems like a really useful new tool for sort of a way to talk about extension. I'm wondering what the stakes are, and this is just a place for you to flex and tell me how cool the project is. Right, it seems like, look, maybe I just want Marcosian's very logical definition, or I can just describe something and say, like, look, this is extended simpliciter, but it's not extended by the Lebesgue measure. Right, so like having these extra tools, these extra ways to describe things, awesome, super useful, I get that. But, I mean, it doesn't seem like there's a right answer here, right? Like, this view isn't going to work if I think that atomic regions of space-time are extended, right? Because the Lebesgue measure is defined on a continuous point in space. And so I'm just wondering where you think the sort of power of this comes in. How exactly do you think that this is going to sort of help out? Right, we have these metaphysical conditions that are, or desiderata that are being sort of imported. And that, it like struck me as a little bit odd, because it doesn't seem like it's a, I mean, I'm going to say it like this, and I don't necessarily want to commit to anything, but like, it doesn't seem like a natural property being extended. It seems like we're sort of, it's a little bit more ad hoc, a little bit more pragmatic than that. And so I'm just wondering where you see the utility of adding this new concept.
Mm-hmm. So thank you for the question. And actually, I tend to be pluralist about the different definition of extension that one might want to use depending on different debates. Okay? I'm not saying that the concept of spatial extension should be just one, taking over all the others. Maybe sometimes, for some metaphysical reason, you are okay to use the meteorological notion of extension because you are interested only in meteorological aspects. sometimes it's useful also to consider theories of a location a little bit more, and also the theoretical tools provided by mathematics in order to talk about not just whether or not an entity is extended, but also whether or not that object brings us a measure of extension of a particular value. The point is that, as I was trying to show, if you use the methodological definition of extension, you're not able to provide a measure. Okay, suppose now that I want for some reason, I mean, imagine to be at a hospital, and someone tells you, okay, you have a tumor, and you might not want to say, well, this tumor is extended or just unextended. You want to say exactly, depending on the stage of the tumor, well, it is extended this much. This much. Maybe on a certain level of explanation, okay, if my level of explanation is, oh, do I have a tumor? Yes or no? Well, if you have something with certain characteristics that is extended, yes, you have a tumor. But if you go a little bit beyond that, if you want to say, respond to further questions, take it for granted that yes, you have a tumor, like, okay, at which level my tumor is, first, second, metastasis, and so on, so you might want to attribute a measure to what you call spatial extension. And certainly, so this is kind of a thing. So I think that, the type of notion of spatial extension and also the type of notion measure of extension one might want to endorse, depending on the level of explanation one is acquainted with or one might want to endorse. So this is a first point, and the results of this also apply to metaphysics per se. My project is completely devoted to the metaphysical possibility of the extended simples and the extended complexes. And the literature has been focusing on extended simples in particular, but extended complexes now have been considered again by Pickup, okay, by using a notion of extension that is the methodological one. In order to be unextended, you must be located just at one point. But this is a lot of taking for granted here, because you consider conceptualization of space composed of an extended point, and you want to say, well, there are many parts, okay, that are located at one point. But what if I change the definition of extension here, and I say, well, no, I'm talking about the back extension, okay, and I take for granted that point, that maybe there is a way to justify, metaphysically speaking, the metaphysical possibility of unextended complexes. So at this point, the payoffs of this can also reach that part. So it depends, on what you are focusing, I would say, your attention. But this account, okay, this new account, but also the other accounts have been focusing on metaphysical debates, so in particular on the metaphysical possibility of extended simples and extended complexes. But if you think a little bit further about this, you apply this to also the metaphysics of persistence. The first thing that you say for an object, in the relativistic context, to be to persist, is to say, well, the exact location of that object, called it R, is not achronal, okay? And
is that what?
Achronal. Maybe I'm pronouncing that not correct. Achronal. It's not achronal. And they use, for instance, Dalhousie and Fano use a definition of extension depending on the conjunction of 2 points of the region through time-like vector and so on. But they also say, well, this point can be, a little bit challenging, because we're endorsing this definition of extension, and measure of extension, but we're not completely clear whether or not it should be the case. So we're a little bit, from now on we assume this, but maybe some other accounts will pop up in the future, and a new notion, of spatial extension will be endorsed, and so also the debate that we're leading will need to be completely addressed again in a different way. So, this is just a very basic way to say, well, talking about spatial extension, even though it emerges from the spatial location, is of importance, because it reaches different levels of explanations within different metaphysical debates.
Cool. Sounds like a cool point. Thanks.
Any other questions?
No one else?
I can ask one as well.
No,
You go.
if if I get started, this one will take a few minutes, and I don't want to hold off other people, so
All right,
take
sure.
other questions
Yeah, sure.
first.
Go for it.
Okay. Well, mine's a kind of dummy question. It's not my area at all, but one thing I was interested in was the bit where you talked about the measures being infinitesimal. The theory allows that. But I'm sorry, I didn't quite catch the motivation for that. And also I was wondering about the metaphysical implications of allowing those infinitesimal measurements. Means that things mean that objects are infinitely divisible or something like that, or can you block that? The idea of infinite divisibility. So yeah, just if you could say more about the infinitesimal bit, that piqued my interest.
Let's start from the point that an infinitesimal is an extended, not literal definition of extension we use, but it's an extension of using the infinitesimals in a way of extending the way in which we use the real numbers. And an infinitesimal, okay, in R1, so one-dimensional infinitesimal is an extended real number such that that number is always greater than 0 and less than every other real numbers, okay? And they are routinely used in mathematical analysis, for instance. And it does not prevent you from saying, well, you can always continue to divide, because you can also impose then an order among the infinitesimals, so you can continue to do what you were doing with the real numbers, but using also infinitesimal numbers. Well, the motivation here was imposed by the fact that, on which I probably should have pressed a little bit more, I was taking these, anyway, I was taking for granted, okay, a metaphysical principle according to which if something is extended and you consider the measure of extension of that object, you cannot have that according to your account, okay, maybe using just Mology, that thing is extended while having a measure of extension that is equal to 0. So if something is extended, must have a degree of extension that is greater than 0, so positive, okay, in particular if you use real numbers. The point here is that, well, with my definition of extension, okay, you can have things that are extended simpliciter, but not Lebesgue extended, okay? So in that case, you cannot say that the measure of extension of that object is the Lebesgue measure, because the Lebesgue measure of it is equal to 0. And you want to respect, again, this metaphysical principle, okay? So a possible way to do so is to say, well, how can I do that? Maybe I can say that when I attribute a degree of extension to objects, the real numbers are not enough. I should go beyond the real numbers. And since I'm using the Lebesgue measure, it is a tool of mathematical analysis, using also other mathematical tools of mathematical analysis, like infinitesimal numbers. I mean, at this point, the Lebesgue measure, if we are committed, okay, ontologically committed to the Lebesgue measure, we are also ontologically committed to infinitesimals, because in order to construct all the Lebesgue theory, you have to construct, you have to take for granted a lot about the infinitesimals, okay? So there is no more constraint or more than what I said when I took the infinitesimal. They were just the natural consequence, okay, for respecting these while remaining within the framework. In order to respond and to give an answer to this fact, you can have something extended simpliciter while being Lebesgue and extended.
Paul?
Oh, please, go ahead.
Richard?
I'm sure.
Okay. Yeah, so when you were responding to my comments, when you mentioned string theory, I was like, yes, that's it, like exactly the sort of thing I was like looking for or hoping that you might mention. The idea that like, you know, something to motivate it that's like, you know, physical. So like, yeah, if we just think we're three-dimensional, living in a three-dimensional space, but we're really these composites of you know, one-dimensional things that we all add up to Lebesgue measure 0, that's the sort of thing I could see like motivating the desiderata, because otherwise it's just like, you know, it feels like, it just feels sometimes like it's just getting a little too carried away with the mathematics. Like I all about bringing in conceptual tools for mathematics and applying them in philosophy to show how they can do work. But sometimes, like in certain situations, it's can be easy to just get a little lost in the details of the map. Like yes, there's all these different, many different dimensions we can consider, and different entities will vary for their being extended or not based on where they are. That's an issue in mathematical context. But I just would like to know why it's an issue in the physical domain. And I'm not skeptical, like I don't think that there's no reason, far from it. But like, just to hear about the kind of cases that this account is concerned with capturing, and why, we want, it to like, so the string theory thing, that sort of case makes sense to me. But when you were talking about one dimension being the most fundamental, that like puzzled me a little bit. Like the idea that but it's interesting. I've never thought about this before. But the idea that like space, three-dimensional space, is ultimately built out of three one-dimensional spaces. So the idea that like one-dimensional space is somehow fundamental, and that that might imply that like when we think about material objects that are extended in all three dimensions, what really matters is their like individual extensions in each dimension. That's a really like novel idea that like I haven't heard before. So that's why I didn't want to like mention stuff like string theory, because I thought maybe you had something else in mind, like something like this. I didn't want to like put any ideas out there that if they weren't out there. But yeah, like do you see like?
No, I see what you're saying,
Yeah.
and obviously I'm not saying that you can take it for granted or take it home without any cost. For instance, the way in which I responded to you takes for granted that I'm constructing out these objects, from a basic, kind of basic level. So I'm prioritizing parts to whole, while maybe according to some other accounts, or I don't know, take listening, it says according to the quantumism, the quantum function is the whole, and everything in this word is a part of it. So you will have exactly the opposite scenario if you want to put that in these terms. So obviously I took a lot from that in this, but I think that the ultimate points that the project would like to tackle are exactly these ones. So not just to be okay with the fact of formalizing a mathematical way and some features, regarding spatial location, spatial extension, and also immerse them in the debate, regarding the priority of parts to the whole, or vice versa, or consider also physical debates on philosophy of physics. So yes, and in any case, strings. It might be the case that strings are not the constituents of these words, because it's not a theory that was proved, empirically.
But it's an example. It's a case that it's an example of like this is the sort of theory that physicists could put out there. Like it's worth even just it doesn't have to be accepted or anything.
And the last thing is also that apart from taking for granted in my response the priority of parts of the whole, I'm also considering the fact when I told you when I was mentioning the fundamental aspect, I took for granted that all fundamental entities are located at the same level somehow, because it was like, okay, I'm taking fundamental level, but what is a fundamental level? It's exactly the level, the space, where fundamental entities are located. But it might be the case that different fundamental entities are not located at the same level of reality, at the same space, if you want to do that in these terms. So in that case, you have to deal with different spaces, maybe with different dimensions, and you don't.
Are you thinking like emergence, kind of, like where you have fundamental entities at higher size scales, or even emergent dimensions?
Yeah. This is just a way, not a way to say to you, we should take this for granted, and we should just construct our debate regarding spatial extension taking that for granted. No, it's just a way that there is much more to say about this concept.
Yeah.
And also these 3/4 accounts of spatial extension in order to make them compatible also with the way in which we think of these metaphysical debates.
We're out of time, so let's thank